This presentation will highlight streaming data in RITdb, the creation of a modern data infrastructure for the semiconductor backend. The proposed RITdb standard was sponsored by SemiCast, the Collaborative Alliance for Semiconductor Test. The final draft of the specification is in development and will go to ballot in third quarter of this year. The standard provides a standardized approach for sharing data and consumption of data throughout the IC manufacturing process. It applies to all data collected in the production, assembly, and testing of semiconductors. It supports smart adaptive tests with the ability to feed back or forward data, including the ability to deploy machine learning algorithms to enhance yield or improve operations. It addresses challenges of data sharing between internal and external facilities and stakeholders. Security and provenance of the RITdb data is critical to enable integrity of the data pipeline. RITdb is a foundation for smart manufacturing. RITdb features include RITdb containers and/or streams of data capable of integrating batch data with individual streams. RITdb bidirectional messaging is the ability to exchange information between the test cell and anything connected to the RITdb infrastructure. This includes data or control. It enables operational control and data analytics. This is built upon an IoT infrastructure using MQTT messaging protocol, a modern open source message-based communication enabling plug-and-play tools and applications. It adds layer of security with public-private key sharing rules and easily integrates into the big data infrastructure. The logical model of a test cell is shown. This shows a broker on the cell, which allows messaging within the cell, as well as sending data off the cell to a broker on the floor. RITdb has many benefits. It enables a data-driven environment, provides standard-based data capture, transport, and relationship model, and supports a variety of use cases beyond just a test data log. It is based on open source software, enables easy data exchange, and provides an infrastructure for the addition of IoT on the test floor. Industry deployment has begun. TI and RIS Instruments have partnered to do several case studies and build prototypes of the RITdb system. RIS Instruments has implemented RITdb, Cohu has implemented RITdb data log containers, and Advantest is developing RITdb capability with the plans to do a demonstration in third quarter. Streaming RITdb supports the integration of industrial IoT smart test strategies to solve quality and cost problems. IoT-based applications can be used to solve test challenges with the RITdb messaging standard and have been demonstrated to work with legacy equipment. This enables the move to distributed applications and deployment of analytics on the edge. This would facilitate the integration of prescriptive maintenance, active monitoring, and acting on data, etc. One of the case studies was the development of a rule manager. This rule manager could combine real-time data and events, windowed data and historical data, monitor that data for some defined behavior, act upon the signal, and send back a message to the system which indicated some response or request to act upon the results. This could be immediate within the domain of the cell, off the tester, within the factory, or sometime later sent to product engineers in the business. For example, an engineer in the US could monitor activity in Asia and be notified of a potential issue via an encrypted text. Rule Manager could be used to support process control, operations control, product engineering, etc. RITdb infrastructure enables the implementation of resource tracking, a real-time location system enabling inventory and failure tracking. This promotes robust data provenance and facilitates the integration of disparate sources of data generated within the test cell. Some areas of impact would be improved data correlations such as test data and sensor data, enhance preventative diagnostics. For example, repeated failures of resources can be found through data analysis and shown that there may be another issue behind the frequent resource changes or failures. Reduce time spent debugging resources, as well as reduce planning and operational costs of tracking inventory and ordering incorrect number of resources. Another feature that was evaluated and identified as being promoted by RITdb is the ability to integrate data playback into the infrastructure. This allows us to replay data in accelerated time. Several benefits come from that: the ability to robustly evaluate software updates before they're deployed to the operation, to evaluate the changing of rules before they're released to production and identify the impact of those rule changes on the floor for the historical data and the potential impact on future uh, products under test. It's time to join. POC studies and test cases have been run. Implementation work has been done. Vendor integrations done or in progress. Tools and examples are available. And the standard is getting ready for semi-ballot and 3Q. What can you do? Participate in the RITdb task force and learn about the upcoming spec. Thursday morning sessions discussing RITdb concepts will start up in August. Or, if you feel like working on the future of test, please join SemiCast. You can contact Paul Trio. Information is below. Thank you for your time.